Welcome to Best Math and Science Videos, Density, Mass, and Volume. To understand density, suppose you have an object that is made up of particles. They may be atoms or molecules. To simplify things, suppose they are all the same type of particle. The size of the object is its volume, and each of the particles has a mass, so we could measure the total mass of the object. The density of the object is its total mass divided by its volume. We can write this as an equation. The density d equals the mass m divided by the volume v. Think about how density can change. Suppose we have another object that is the same size, but it is made up of fewer particles. The objects have the same volume, but a different mass. If the volumes are the same, then the one with the greater mass has a higher density, and the one with less mass has a lower density. But now consider the case when the volumes are not the same. These objects have the same mass, but a different volume. When the mass is the same, the object with the larger volume has a lower density, and the one with the smaller volume has a higher density. In this model, you can see the higher density with how the particles are closer together. So density equals mass divided by volume. But you can rearrange the formula to solve for either density, mass, or volume, depending on the problem you need to solve. A quick way to remember the formula you need to use is to draw a circle and divide it in half. Place m for mass at the top, then divide the bottom part and place d for density on the left and v for volume on the right. The diagram shows that the formula for density d is m over v. The diagram also shows that volume is mass divided by density. Volume V is m over d. And the diagram also shows that mass equals density times volume. Mass m is d times v. So using these formulas, let's now look at how to solve density problems. Consider this question. A piece of copper has a volume of 6.55 cubic centimeters. Its mass is 58.7 grams. What is its density? What do we know about this question? We are told that the mass is 58.7 grams and that the volume of the copper is 6.55 cubic centimeters. And what is not known? We have to calculate the density. The problem is a straightforward use of the density formula. Density equals mass divided by volume. So just substitute the known values. The mass is 58.7 grams, and the volume is 6.55 cubic centimeters. Using a calculator, we divide to find that the density is 8.96 grams per cubic centimeter. And that's your answer. Here's another question. A 5.80-liter container is filled with nitrogen gas. The density of the gas is 1.2328 grams per liter. What is the mass of the gas? We are told that the volume is 5.80 liters, and the density is 1.2328 grams per liter. We want to know the mass of the gas. So let's look again at the three formulas. Since we want to solve for the mass, we use the formula m equals d times v. And again, we just substitute the given values. The density is 1.2328 grams per liter, and we multiply it by the volume, 5.80 liters. The liters cancel, so the units are grams. Multiplying on a calculator gives the value 7.15024 grams. It's very important to write the answer using the correct significant figures. When multiplying or dividing, as we are here, the answer should be rounded to the same number of significant figures as the measurement with the least number of significant figures. The mass value has 5 significant figures, and the volume value has 3 significant figures. So we round the answer to 7.15 grams, which has 3 significant figures. And that's your answer. Let's look at another example. A beaker has a mass of 315.6 grams. When filled with 175 milliliters of a liquid, The mass of the beaker and the liquid together is 536.1 grams. What is the density of the liquid? In this case, we know that the mass of the beaker, MB, is 315.6 grams, and the mass of the beaker plus the mass of the liquid is 536.1 grams, and the volume of the liquid is 175 milliliters. We want to know the density of the liquid. So what formula should we use? We want to know the density, so we use D equals M divided by V, or in this case, the density of the liquid, dL, equals the mass of the liquid, ml, divided by the volume of the liquid, VL. We need to start by finding the mass of the liquid. We are told the mass of the beaker plus the mass of the liquid equals 536.1 grams. So let's solve this equation for the mass of the liquid. ml equals 536.1 grams minus mb. And now substitute the mass of the beaker, 315.6 grams. Subtracting, we find that the mass of the liquid is 220.5 grams. We can now use this in the density equation. The density of the liquid equals the mass of the liquid, 220.5 grams, divided by the volume of the liquid, 175 milliliters. Using a calculator, we find that the density of the liquid is 1.26 grams per milliliter. Let's check our significant figures. The mass of the liquid has 4 significant figures, and the volume of the liquid has 3 significant figures. So we want to express the answer with 3 significant figures. The number we have is correct, 3 significant figures. So that's your answer. Let's look at one more example. The density of acetic acid is 1,049 grams per liter. What volume of acetic acid would have a mass of 1.32 kilograms? Write the answer in milliliters. We know that the density is 1,049 grams per liter, and that the mass is 1.32 kilograms. We want to know what the volume is. So what formula should we use? To find the volume, use V equals M divided by D. So let's calculate it. The mass is 1.32 kilograms, and the density is 1,049 grams per liter. Before calculating, let's look at the units. Notice that we have kilograms in the numerator and grams in the denominator. We need to have the same mass units, so let's use this unit conversion. I've chosen this conversion because 1,000 grams is equal to 1 kilogram, so we're not changing the value when we multiply by this. We're only changing the units. And we put grams in the numerator and kilograms in the denominator so that we can cancel units. If you are unsure why we can do this, watch our video on converting units. So now, the kilograms cancel and the grams cancel. And we can use a calculator to find that the volume is 1.258 liters. But notice that the unit is now liters. We were told to write the answer in milliliters. So we can convert units again. This time, we multiply by 1,000 milliliters divided by 1 liter. The liters cancel. And using a calculator, we find that the answer is 1,258 milliliters. But be careful here. This isn't quite the answer we need. We always need to check for significant figures. So look back at the given information. The density was stated using 4 significant figures, and the mass was stated with 3. The least number is 3. So we need the answer to also have 3 significant figures. In this case, then, the answer should be rounded to 1.26 times 10 to the 3 milliliters. And here also, if you're unfamiliar with scientific notation, check out our video on that. So this is your answer. This video describes how to solve density, mass, and volume problems. You can learn a lot from Best Math and Science videos. Click to subscribe so you don't miss any of them. Thanks for watching. See you next time.